Complete solution of class 10 mathematics under the syllabus of Board of Secondary Education Manipur. Solved, recorded and edited by I. Salamegasandra Singh, lecturer, Sursan Higher Secondary School in Phon. Fill properties of real numbers under addition. Closure property: for x, y belongs to R, x plus y belongs to R. Any real number anigi samsi always real number oi masibu closure property kawi under addition. Commutative property: for x, y belongs to R, x plus y equal to y plus x. Real number any two real numbers ki samsi order mathang manau natraga ahan akongi maka ponde matam pumna makta masibu closure property kawi under addition. Associative property: for x, y, z belong to R, x plus y plus z equal to x plus y plus z. Any three real numbers singi sum asi grouping gi makha ponde x plus y da z hapsin baga y plus z te x hapsin baga phol chap manai any three real numbers sing masibu associative property go under addition. Existence of additive identity. Existence of additive identity element: for x belongs to R, there exists 0 belongs to R such that x plus 0 is x. Any real number x haiba amaga 0 ga tinsinabada always any real number x tarabadi mafam asida additive identity element lay haigani set of real numbers ta masigi 0 asiba ikhoina kari kawi additive identity element kawi. Existence of additive inverse: for x belongs to R, x have a c any real number amani, there exists minus x belongs to R such that x plus of minus x is 0. X haiba any real number amagi minus x haiba any real number amal laigani makoi anigi sum adu 0 taba mafam asida minus x asibu x ki additive inverse kawi. Under multiplication, prime property of real numbers say under multiplication the mokhana say 1. Closure property. Closure property: a for x, y belongs to R, x, y belongs to R. Any real number anigi product si matam punamakta real number oi masibu closure property holds for multiplication. Commutative property: for x, y belongs to R, x, y equal to y into x. Any real number anigi product si ahan akon gi makha ponde order gi makha ponde masibu commutative property chummi sumakawi. Associative property: for x, y, z belong to R, x, y into z equal to x into of y, z. Real number ahungi product si grouping gi makha ponde matam pumna makta masibu associative property holds for multiplication. Existence of multiplicative identity: for x, x does not equal 0 belongs to R, there exists 1 belongs to R such that x into 1 is x. 0 nataba any real number ama khudingi real number da 1 haiba ama laigani x ka 1 ga purinabagi foldu x tagani. Masigi 1 asibu aikoina multiplicative identity element kawi. Existence of multiplicative inverse: for x which does not equal to 0 belongs to R, there exists 1 by x belongs to R such that x into 1 by x is equal to 1. 0 nataba real number ama khudingi 1 by x haibama real number ama hekta laigani karamna x amasung 1 by x mabani gi purinaba multiplication adu 1 always tagani. 1 by x asibu x haiba non-zero asigi multiplicative inverse kawi mafam asida 0 gidi multiplicative inverse laikte masima khangjen gadabani. Z manai masibu khoina real number singi multiplication si distribute over addition kawi. 2. If x, y, z belong to R and x plus y equal to x plus z, then prove that a y equal to z. X, y, z have a real number ahumni x plus y ki value ga x plus z ki value ga manaraba adu rabadi y ga z ka managani pramanto. here x plus y equal to x plus z. Masima pirame apibasi aikoni equation 1 haina kaurani. For x belongs to R minus x belongs to R. Real number x haiba amagi minus x haiba ma real number de yaugani. Adding minus x to both sides of equation 1 we get equation 1 gi nakan animakta minus x hapsin si manaba quantity animakta hapsin bada equal to the ahongba laite. That is this minus x plus y equal to minus x plus z. Real number sing tinsinabasi commutative property holds or high minus s ka x ka anisi grouping sagaro y left out minus s ka x ka anisi grouping sagaro z left out adudi grouping gi makha pondabanina associativity of addition of real numbers to chume minus s ka plus s ka tinsinaradi 0 tarani we get 0 phange sigi 0 phange atai sinilengdana thamani masigi property se kari kawe property of additive inverse. Any real number amaga mahaki additive inverse ka samduri 0 tagani aduna masigi property seasonariba property si property of additive inverse kawe 0 ga any number ka tensionaradi any number tai aduri 0 plus y gisu y tarani 0 plus z gisu z tarani masibu property of additive identity gi magun season number ka tension any number tai hence proof. 3. If x, y, z belong to R, x does not equal to 0 and x, y equal to x, z, then prove that y equal to z. X, y, z any real numbers ni x di 0 uhinngum sil x, y ki product ka x, z ki product ka mana rabadi y ka z ka mana gani pramanto. Here x, y equal to x, z equation 1 haina khangna rasi. For x does not equal to 0, x to 0 nataba number nina there exists 1 by x belongs to R. 1 by x haiba a real number ama real laigani. High river real number sina multiplying by 1 by x to both sides of equation 1 we get equation 1 sigi nakan ani magta 1 by x na puri rasi maramdi 1 by x real number ama oire. We have this. Real number sing puri nabasi associative property holds oi adudi 1 by s ka grouping sagrasi sigi 1 by s ka grouping sagrasi z left out horasi season nariba property the associativity of multiplication of real numbers ni 1 by s ka puri nabagi fall di 1 tarane 1 lere sigi su 1 lere ni property of multiplicative inverse ka any real number ga real number amaga mahaki multiplicative inverse ka purinaradi 1 tagani identity element si 1 ga any number ka purinarabadi any number do tagani 1 into y di y tagani 1 into z di z tagani seasonary property di property of multiplicative identity element ne masida identity si y walame. Prove that for any x belongs to R, x into 0 is 0. Real number x haiba amaga 0 ga purinabagi false 0 tagani habisi praman toksi. We have 0 plus 0 is 0 property of additive identity. Any real number amaga 0 ga adding tau any real number 0 ro tagare. Simo koi khang kare x na both sides multiply taro x multiplying x on both sides we get this. Distributive property holds oirabanina x into 0 plus x into 0 equal to x into x. Distributive law seasonary. Hozik nakan animagtagi x into 0 si x into 0 si nakan 0 hapsin lo any real number ama the 0 hapsin ba si phone ahong malaite. The property of additive identity si 0 sibuni additive identity hari si right hapsin bani. Manabasin kakhakrabade x into 0 kakakra x into 0 kakakra x into 0 lehore sig 0 lehore nakan animaktagi manaba tamsing lotho kare masibu kari kawi cancellation law panjal laga si phange x into 0 is 0 real number amaga 0 ga purinabagi false 0 tagani have praman to praman tore 5. Prove that for any x, y belong to R, x into minus y is equal to minus times of x, y. X amasung y habasi any two real numbers ni x ka minus y ka purinabagi policy minus times of x, y ka managani pramanto. We have x into minus y plus xy equal to x into minus y plus y distributive law ni mafam asida sizinaribasi over addition da. Hariba tam ani asidagi my x kama lokthokradi ahanba tamgina minus y lehore ani suba tamgina plus y lehore. Then minus y ga plus y ga tinsinarabadi 0 phangani additive inverse sizinare. Y ga mahaki additive inverse minus y ga sum up tordi 0 tagani. 0 into any real number de 0 laigani. Multiplicative property of 0. 0 ga any number ga purinabagi rule sizinare. Number ani ga sum na 0 chatlabadi. Number ani tam ani sigi sum sinu 0 chatlabadi. Tam ani se amana amagi additive inverse ne. X into minus y asi sigi xy asi mahaki inverse ore maramni mahaka sum to 0 tarabadi mahak ase kanagi inverse no sigi ahan batam sigi or ahan batam se ani suba tamgi inverse ni adubu mafam asida x into minus y asi equal to xy ga minus xy ga manare, hence proof. 6. Prove that for xy belong to R minus x into minus y is equal to xy. Real number anigi minus x ka minus y ka purinabagi fall to xy tagani ulo. Solution. Minus x into minus y is equal to minus kamalog to ani x ka minus x ka y ka purinarani sigi property x into minus y as c minus times of xy ka mane haba property to seasonary. Amokso minus x ka y ka purinarabadi commutative property holds oirabanina minus x ka y ka interchange taunakre. Commutative property of multiplication pale. Next, sigi minus asi mamangda lokthokrani x into minus y asi minus xy ka mane haba property to seasonarabadi x ki mamangda leba minus 2 y x ani ki product ki mamangda thame. Minus of minus te kari tagani. Let's see. Amuksu commit x y into x habasi xy ga manai mafam asida seasonariba property di commutative property of multiplication seasonare y x ka xy ga manai. Next, xy phange additive inverse of minus xy is xy minus xy ki additive minus xy ki additive inverse ti minus xy ki additive inverse ti xy ni minus xy hariba number asigi additive inverse ti xy orane, hence proof. If xy belong to R and xy their product is 0, then prove that either x is 0 or y is 0. Real number anigi product na 0 oirabadi anidugi manungda amadi soidana 0 oigani. Yamdrabada ama 0 oigani. Yamna maming leiba property ni. Solution. If x does not equal to 0, x na 0 oirabadi, then there exists 1 by x belongs to R. 0 nataba any real number amagi multiplicative inverse ti always real number oigani. Then xy is 0, it is given 1 by x na both sides na multiply torabadi 1 by x times of xy equal to 1 by x into 0. Associative property pansi grouping wafam laksi implies 1 by x ka x grouping sagaro y left out toro 1 by x into 0 di 0 tagani. 0 की multiplicative property sizinaraga 1 by x का purinarabadi 1 tagani. Real number amaga mahaki multiplicative inverse ka purinarabadi 1 tagani have a property to sinasi 1 ga any real number amaga purinarabadi any real number do tagani mafam asiro y tare y 0 lare. X na 0 natrabadi y 0 oigani. Again, if y does not equal to 0, then 1 by y belongs to R. Sama na ba mawong da y na 0 natrabadi 1 by y asi R da yaugani. Then xy equal to 0 implies xy 1 by y na both side ta purirasi 1 by y na both side puiro right agi multiply toro distributive property associative property seasonality y ga 1 bo y ga 0 ga any real number puri 0 tarani y into 1 by y di 1 leirani x into 1 di x tarani 0 ahanbada x 0 nataba oiba matamda y hekta 0 oirami y 0 nataba lauruba matamda x 0 hekta oirami. Thus x y equal to 0 implies x equal to 0 or y equal to 0. Real number ani ge product na 0 oirabadi ani dugi either x equal to 0 or y equal to 0 or both ani muk 0 oiristu chungmani. Hence proof. Absolute value or modulus of a real number. Real number amagi absolute value karina, real number amagi modulus karina. The absolute value of a real number x denoted by x with single bar taken bar is defined as absolute value of x is x when x is greater than 0 or equal to 0 and whose value is minus x when x is less than 0. X na negative oirabadi negative amagi absolute value di x na negative oirabadi minus x oigani. X na positive oirabadi outcome asama oigani. X na even 0 oiraba how the outcome 0 oigani. Right tarakli ba value sing asi 0 natraga positive number ni negative amata yaugde. Absolute value of a real number is its we have to consider its numerical value only with neglecting sign waphamne. Properties concerning absolute values of real numbers. Real numbers sing absolute values sing properties sing kari yang se modulus of x is greater than or equal to 0. Any real number x haiba amagi absolute value si 0 dagi sauba positive number or equal to 0. 0 oiba natraga positive number oigani negative wafam sugan khanaroi. Point number 2. Absolute value of minus x is equal to absolute value of x. Any real number amagi absolute value ga mahaki additive inverse ki absolute value ga matampuna makta managani. Point number 3. Product of xy is equal to modulus of xy is equal to modulus of x into modulus of y. Real number ani ke product ki modulus asidi modulus of product of real numbers. Modulus of x plus y is less than or equal to modulus of x plus modulus of y. Triangle inequality kawi. Real number ani ke sum gi modulus ase real number singadugi modulus singi sum dagi pikkani natraga managani. Modulus of x minus y is greater than or equal to modulus of x minus modulus of y. And modulus of x minus y is greater than or equal to modulus of y minus modulus of x. Real number anigi distance number line da laiba distance ki distance asi number sing adugi absolute value anidugi khenabadagi chaugani natraga managani haibani. Modulus of x minus y is less than delta if and only if y minus delta less than x less than y plus delta. Real number line da real number anigi distance asi delta hariba number asidigi piklabadi madu karama matamda chungmani adugumba number adu y minus delta amasung y plus delta anigi marakta laigani haibani. Prove that modulus of x minus y is less than delta if and only if y minus delta less than x less than y plus delta. Let us prove. Suppose modulus of x minus y is less than delta. Ahan big statement si chumi pirame hana lawrasi. X minus y is less than delta. Number line da x amas y gi arapa asi delta de gi pikle haibani. Sinakari x minus y is less than or equal to x minus y. We have learned that x minus y is less than or equal to x minus y. Simasukoi khangare. And minus of x minus y is less than or equal to x modulus of x minus y. Then x minus y di kaya dagi mahak ti kanadagi sau khare mahak ti del mangondagi sau number di delta na sindokro mangondagi sau number su delta na sindokro equal to yaram badu hojik yaroi mafam asida modulus of x minus y dagi sau ba manadaba number di delta ne. Sidigi mafam asidigi kon x to solve tausi x or minus y na delta ga nakanda thangra y plus delta mafam asidisu x solve tausi minus x na right thangra minus x na right thangra y ga nakanda delta pura y minus delta less than x x asi kanadagi pe y plus delta regi x asi kanadagi chawi ma y minus delta regi ani asi bu punna shortly asun ibi does y minus delta is less than x and which is again less than y plus delta. Hence, first part to the converse part wali. Conversely, suppose y minus delta less than x less than y plus delta. Masi amuk suppose torasi aikoi gidi modulus of x minus y is less than delta prove to gadabani. Y minus delta less than x habama anithona tugairasi x is less than y plus delta amuk part anithona tugairasi masibu. Mafam asigi x minus x to left thang or minus delta do right thang plus lere aduga minus kamalok thoksi asumna thamba yai mafam asigi su y jin x kina kana thang khradi x minus y delta lengdana thamoro minus of x minus y is less than delta x plus y is less than delta nakan ani maktadi adu rabade makhoi ani mak delta regi pitlagadi common statement that the modulus of x minus y is less than delta, right? The hence statement is converse to prove tore. Hence the statement is proved. Exercise 1.3. Question number 1. Examine whether the following statements are true or false. Makhagi statements sing a si sumina tragalandi naino. The reciprocant of an irrational number is irrational. Irrational number amagi reciprocant si irrational oi haibani. Suppose root 2 hari ba irrational number sigi reciprocant di 1 by root 2 ni. Masi irrational oi. Asumna 2 plus root 3 haibasigi reciprocant di 2 plus root over 3 ni. Makoi khudingmak loina irrational oi. The pyramid statement is true. True. The set of natural numbers contains additive identity. The set of natural numbers contains additive identity haibani. Natural numbers singi masing kanglupta tinsinabagi identity limen yawe haibani. Additive haibadi any real natural number amaga karigumba real number ama natural number amaga tinsinabadi x ta hanba ngamba adugumba number natural number de libra x haiba any natural number amada atopa natural number amakhak leiradi amakhak leigani madu hapchillaga x ta hanba ngamba adugumba natural number leibra x haiba sida 1 hapchillo x plus 1 phangi x ta 2 hapchillo x plus 2 phangi leite statement ase the whole number that is to me x haiba siga any number 0 siga adding to the any number x to type 0 the whole number yaw but sida di 0 is a natural number ge masing kanglop to yawde. This pyramid statement is still the set of integers has multiplicative identity. Set of integers that has multiplicative identity legani hai. The set of integers has multiplicative identity. Any integer amaga number amaga purinaraga any number to tab. Adugumba number libra set of integers da. Integers ki masing kanglupta lay. There is one. Statement asi lay harabanina sumber lambar harade chumi. There is one. One ga any one of integers ga any integer ma puino any integer x tagan. The reciprocant of a non-zero rational number is rational. Rational number 0 nataba rational number amagi reciprocant 0 nataba rational number amagi reciprocant 2 hariba rational number asigi mahaki 0 nate reciprocant rational oi 1 by 2 gisu 2 oi multiplicate reciprocant haro the mathamaka ona bani makoi gi production delay. The statement is said number 4 the reciprocant of a non-zero rational number is 0 nataba yes true. Number 5 the operation of subtraction in R is commutative. Real number ani khaidok na basi commutative oi have a system chumbra hai bani 2 dagi 3 khaidok pagi phone ga 3 dagi 2 khaidok phone ga manade aduna the operation of subtraction in a set of real numbers is commutative have a statement is false ni. The operation of division in R is associative haibani. Integersing tinjinabasi grouping gi makha ponde haibani. Lali statement asi lali. Division da di amthina lan kare. Integer ahum yena say to the 3 ni yen bagi polsiga amuk 4 ni yalu sigi polsiga 2 divided by 3 divided by 4 se polamata manaro. Roman number 6 statement is false ni. Question number 2. A. Is there any real number x such that 1 by x does not contain in R? Real number x haiba amagi reciprocant to real number oidable laibra. Yes. That is 0. 0 haibasi real number ni mahaki reciprocant 1 by 0 haibasi real number the yaugdi undefined number ni. B. Is there any x belongs to R such that minus x does not belong to R? Real number x haiba amagi additive inverse to real number oidable laibra? No. Answer is only for any x belongs to R implies minus x belongs to R. Real number x haiba amagi additive inverse always real number oi. Is there any x belongs to R such that x square is not positive? Real number x haiba amagi square do positive oidaba real number laibra? Yes, the number is 0. Is there any x belongs to R such that x square is negative? Real number the x haiba real number amagi square and negative oiba laibra? No, for any x belongs to R implies x square is greater than equal to 0. Negative real number amagi square is negative oiba ngamde. Can two different real numbers have the same absolute value? Manadaba number ani ge absolute value manaba ngambra? Yes, ngame. Minus 2 ge absolute value is 2 ni, 2 ge absolute value is 2 ni, minus 2 amasung 2 manade. Yes, absolute value of minus 2 is 2 and absolute value of positive 2 is also 2. Manadaba number minus 2 amasung 2 ge absolute value manaba yai. Question number 3. If absolute value of A is equal to absolute value of B, find all possible relations between A and B. Number A amasung B haiba ani ge absolute value manarabadi A ga B ga marakta leba relation pumnamak putho haibani. Here, absolute value of A is equal to absolute value of B. When A B greater than equal to 0, then A equal to B. A amasung B si non-negative number singoirabadi makhoi gi absolute value singdi A orani, A ga absolute value si A orani, B ga absolute value si B orani. Mabani managani. When A and B less than 0, A amasung B si negative orabadi, then A gi maki absolute value di minus A orani, B na negative orabadi maki absolute value di minus B orani. Minus 1 on both sides to put A equal to B orani. When A is positive and B is negative, A na positive, B na negative orabadi, A positive ke absolute value di masamak larani, B na negative orabadi maha ke absolute value di minus B orani. A ga B ga layna gadaba relation di A equal to minus times of B. When A is negative and B is positive, then A na negative orabadi negative ke absolute value di minus A ni, B na positive orabadi maha ke absolute value di B masamang ni. Minus 1 na nakanani magpuri A equal to minus B ga managani. Thus, all possible relations between A and B are either A equal to B or A is equal to minus B. Question number 4. Give any three values of x satisfying absolute value of x minus 3 is less than 1. Absolute value of x minus 3 is less than 1. Property palagade. Absolute value of x minus y is less than delta implies y minus delta less than x less than y plus delta. Hariba property si palagadi mafam asida x adu mojare y asidi mas 3 ore delta di 1 ore property palagadi 3 minus 1 less than x less than 3 plus 1. That is 2x is lying between 2 and 4. 2 amasung 4 gi marakta laiba number ahum hairagadi 2 dagi sauba 4 fi number di masing tingamna lere. Keep any three values of x haibani. Thus, the three values satisfying these are 2 digi solver number 2.5, 2 digi solver 3 digi 4 digi pick paraga 3 loka pare and 3.5 number ahum si loka le masing tingam na lowe. Question number 5. Find x if number 1 modulus of x minus 2 is equal to 0. Modulus of x minus 2 is equal to 0. That when x minus 2 is greater than equal to 0, non-negative oiba matamdadi mahake absolute value the x minus 2 tagani equal to 0 lejare x solved already 2 bang. When x is less than 0, that is x minus 2 is negative number whatever the negative amag absolute value the minus times of number masamak lerani siga mana hello x value 2 bang. For Roman number hence x value dot 2 Roman number 2 absolute value of x minus 2 is 3. Then when x minus 2 is greater than equal to 0, then positive amana negative amage absolute the masamak tarani do 3 ga mana hello x value of 5 lare. X minus 2 is negative less than 0 have the negative or the negative amage absolute the minus times of masamak larani equal to 3. Chige x solved over the x equal to minus 1. X would to be value sing do the 5 ga minus 1 ga. Hence x equal to 5 or minus 1. 5. Find f. Modulus of x minus 3 is equal to root 2. Here, modulus of x minus 3 is root 2. When x minus 3 is non-negative, have it greater than equal to 0, then whose absolute value is number x minus 3 itself equal to root 2. See x factor of the x equal to 3 plus root 2. When x minus 3 is negative, that is less than 0, then whose absolute value is minus times of x minus 3 and equal to root 2. Like x solved already 3 minus root 2 from it. Hence x go to have a value the 3 plus root 2 or 3 minus root 2. For Roman number 4, when x minus 2 is greater than equal to 0, non-negative or the mahake absolute value the x minus 2 masama oigani equal to x. Dagi x to solve to over the 2 equal to 0. 2 ga 0 ka mana by the oitopia the invalid impossible. When x minus 2 is less than 0, negative number or the mahake absolute value the minus times of masama lerani equal to x to solve to the 1 pange. Hence x value is 1 orani. 6. If a square plus b square equal to 0, prove that a equal to 0 and b equal to 0. A square plus b square is 0 over a and b is real number singni makoi do a is 0 igani b is animak 0 igani heaven. Here a square plus b square 0 it is given. We have x square is greater than equal to 0 for all x belongs to any real number amagi square cd always greater than or equal to 0. Hariba system negative or sunya. So a square and b square are non-negative. A square to b square to negative nataba number singh. But a square plus b square is 0. Negative nataba number singh is samna. Negative nataba number singh is samna 0 or high pyramid wahanga sida. What must be true? Sistumagade. Negative nataba number singh samna 0 or higher a number singh 0 ga manaba natano palete. A square is 0 and b square is 0. A square is 0, that is a is 0 with natano palete. B square is 0, b 0 igani. A must be 0 igani have do. Thus, if a square plus b square is 0, then a equal to 0 and b equal to 0. Hence proof. 7. Identify on number line the points x satisfying modulus of x less than or equal to 3. X cyber real number sigi modulus 2 minus 3 degi pikpa natraga 3 ga manaba madu number line da ta u ye u haibani. Modulus of x less than or equal to 3 haibasi x cyber number sigi modulus 2 3 amasung 3 degi pikpa 3 ga manaba su yai haibani. Masi basum iba yai. x minus 0 property palabade x is lying between 0 minus 3 and less than or equal to x less than or equal to 0 plus 3. That is x habase minus 3 amasung 3 ge marakta laigani animaksu oiba yai. Masin number line asum yekani. The point satisfying modulus of x less than or equal to 3 on number line is the points belong to the segment joining P whose number is minus 3 and Q whose number is 3 as in the figure. 3 amasung minus 3 amasung 3 habedi P amasung Q gi marakta leba point khudingmakna represent tawgani. Hariba sigi marakta leba number khudingmakki absolute value singdu 3 dagi pikani natraga 3 ga managani. Next, here modulus of x is less than 3 hanagan equal to yawe handakin equal to yawdi. X minus 0 hani vi property palabadi 0 minus 3 less than x less than 0 plus 3 mafam asida equal to yaw iste yaw kidabanina. That is minus 3 less than x less than 3 lere. The point satisfying modulus of x less than 3 on the number line is the points belong to the segment joining P whose corresponding number integer is minus 3 and Q whose corresponding integer is 3 excluding the end points P and Q as in the figure. P amasung Q gi marakta lairiba P amasung Q di yaudaba sigi point asidi number line da yaroi number line da sigi point asisu number line da yaroi sigi marakta laiba number khudingmangna chumi sigi marakta laiba number khudingmangna. 7. Identify on the number line the points x satisfying whose absolute value is greater than or equal to 3. Which is x is greater than or equal to 3 or minus x is greater than or equal to 3. X na positive na 0 or the situation x na negative or the magi absolute value is sini. Sidigi x to solve to rabade 3 less than or equal to x or x less than or equal to minus 3. The point satisfying absolute value of x greater than or equal to 3 on the number line is the points on the race px dash and qx is in the figure. Number line da lariba p su yauna px dash lariba point singna aduga q da su q yauna qx gre da lariba point sing khaktana chungani manung da lariba point amatana chumde. For number 3 mafam asida equal to yaugre x greater than 3 or a minus x greater than 3. X to solve to already x greater than 3 or x less than minus 3. The point satisfying absolute value of x greater than 3 on the number line is the points on the rays px dash and qx, excluding the end points p and q as in the figure. Sigi figures the yauriba sigi points simadi number line the yaude from the labor point kudimang na chumi. Q su yaude mahaki right lariba point khudingmak na chumi. 7. Identify on the number line the points x satisfying this. 5. Property palabadi x minus 2 positive negative oirabadi x minus 2 asi less than positive or the negative or the minus na puri running less than this line. So x to solve or the x less than equal to 5 or minus 1 less than equal to x. The point satisfying this inequality on the number line is the points on the line segment PQ as in the figure. Sige PQ the number line as the point kudimana inequality as chumale P su yaugani Q su yaugani equal to yaugani. Thanks for watching.